Hello everyone. We continue with trigonometric ratios for any angle between 0 degree and 360 degree. On this video, we are going to do different types of examples related to this topic. So let's look at example 5. The point -5 and 7 lies on the terminal arm of an angle theta in standard position. Find the primary trig ratios for theta and find theta. So this is going to be a reference example for textbook questions number 2 and 10 on page 299. So first we need to sketch this angle. That should be the first step. Okay, so x coordinate is -5 and y coordinate is 7. So first we found the point -5 and 7. And we know that terminal arm is going to pass through that point. Okay, so because it is in standard position, so we always start drawing angle theta from positive x-axis. So that is our angle theta. Okay, so let's write then primary trigonometric ratios. So we need sine theta, cos theta, and tangent theta. Sine theta, we already learned it from the previous videos that y over r, and cos theta is x coordinate over r, and tangent theta is y over x. So we already have x and y coordinates of this point, but we don't have the r yet. Again, so we can use the referral triangle here. We always build the referral triangle using the x-axis. Okay, so this is our referral triangle, and we know that is going to be the related acute angle. So if you look at this triangle, so this is -5, so this distance is 5, and this is y coordinate is 7, so this distance of triangle is 7. So then we can use Pythagoras here, and we say that r square equals 5 square plus 7 square. So that gives us 25 plus 49. So r square equals 74. So r square root of 74. So actually we get plus and minus square root of 74. However, let's remember this hypotenuse is also the radius for the circle that is created by the rotating arm. So therefore r is always positive, so we only pick the positive value for r, so square root of 74. So then let's write the ratios. Sine theta is y coordinate 7 over r root 74. And we always rationalize the denominator. So multiply this by root 74 over root 74. That gives us 7 times root 74 over 74. So let's write cosine theta, x coordinate, which is -5, over r root 74. Again, we multiply top and bottom by root 74 over root 74. That gives us -5 root 74 over 74. And tangent theta, y coordinate over x coordinate, 7 over -5. But we never keep the negative sign in denominator, so move it to numerator. So that gives us -5 over 5. So -7 over 5. So we answered the first part of the question. We found the primary trigonometric ratios for theta. The next question is find theta. Okay, so when you are working with acute angles, so to get the angle, you directly take the inverse of sine, cosine, or tangent ratio to get the angle. However, if the angle is not acute, then we cannot use the same method. So therefore, we always go with the related acute angle. So now pick one of those ratios. It doesn't matter which one you pick. So I don't want to deal with square roots. So then preferably, I will take tangent theta. I'm going to use this, but again, I'm not going to do tan inverse negative 7 over 5. Okay, so instead I'm going to get the ratio for a related acute angle. Trigonometric ratios for related acute angles always positive, because again that beta is an acute angle. If you sketch it in a Cartesian plane, it is always in the first quadrant, and trig ratios in first quadrant have all have positive values. So then tangent beta is going to be positive 7 over 5. Now we can do tan inverse to get the beta. Tan inverse 7 over 5. So that gives us 54.5 degree. So now in this picture, you can see that 54.5 degree is here. Then to get theta, I need to subtract that beta from 180. So theta is 180 minus 54.5. So if we do the subtraction, we get 125.5 degree. Let's look at example 6. Determine all possible angle measures from theta greater than or equal to 0 as less than or equal to 360 to the nearest degree. So this question is going to be a reference example for number 8 and 9 in your textbook, page 300. So let's start with A. So sine theta is given 0.5879. Again, so in grade 10, so you work with acute angles, and to get the theta, you directly took sine inverse of this value to get the angle. But now we learned that actually in 360 degree, there is more than one angle that has the same ratio. Okay, and we talked about 4 related angles, and we said 2 of them will have positive values and 2 of them are going to have negative values. And we already talked about that bow tie method. So those 4 angles, 1, 2, 3, and 4, they will all have the same value for their ratios, but again 2 of them will be positive, 2 of them will be negative. So in this case, therefore, we cannot just do theta equals sine inverse of that value. We always have to go with beta. So when you're writing the ratio for beta, you use the same number, but you always make it positive if it is negative. Then, now we can use sine inverse to get the related acute angle. So sine inverse 0.5879. So that gives us 36 degree. So beta is 36 degree, not the theta. Then what we can do, we can use cast to know which angles will have positive sign, right? In which quadrants. So cast. So looking at the cast, we know that sine is positive in the first quadrant and in the second quadrant. So I have 2 possible answers here. One is in the first quadrant, and second is in the second quadrant in this case. Okay, and so then in the first quadrant, theta is same as beta. So that is 36 degree. Okay, and in the second quadrant, so remember, always beta is the angle between the terminal arm and the and closest x-axis. So this is beta. Then to get the second angle theta, we need to subtract beta from 180. So 180 minus beta, and that gives us here 144 degrees. So we have 2 possible answers here. So let's look at B. Cos theta equals negative 0.9563. Again, we don't do directly inverse of this value. We always write the ratio for the related acute angle. and then you use the same numerical value, but always make it positive. Then we can do now cosine inverse of 0.9563. So that gives us 17 degree. 17 degree. The next step, we use cast, and looking at originally cos theta is negative value. Now we need to find the quadrants where cosine is negative. So all is positive and cosine is positive. So it looks like quadrant 2 and quadrant 3 cosine values are negative. So therefore we have two angles. One is in quadrant 2 and the other one is in quadrant 3. Okay, and so again the betas are the angle between terminal arm and closest x-axis. So these are our beta values. Okay, now if angle theta is in quadrant 2, then theta would be 180 minus beta. So 180 minus 17 gives us 150. So we do 180 minus 17. So that gives us 163 degree. And the second angle, as you see in quadrant 3, and then we need to add beta to 180 to get the theta. So 180 plus beta. So 180 plus 17 degree gives us 197 degree. Okay, so again you have two answers for this question. So let's look at part C. This time cotangent theta is given 2.7475. We always need to go to related primary trigonometric ratio to be able to solve this. So we can write tangent theta from here. So that's going to give us 1 over 2.7475. So 1 divided by 2.7475. That gives us 0.363, so 40 almost. So tangent theta is 0.3640. Okay. Now again, we never do tan inverse from here. First, we write the ratio for related acute angle. So we are going to use the same number. If it was negative, we would make it positive, but it is positive, so we just keep it as positive. Now we can do tan inverse of this value. Tan inverse 0.3640. So that gives us 20 degree. So beta is 20 degree. Next step, finding theta using cast. So cast. So we need tangent being positive value. Tangent is positive in first quadrant and in the third quadrant. So we have two angles. One is here and the other one is in quadrant 3. Okay, so for quadrant 1, we know that theta equals beta. Again, so we can also mark the betas here. Okay, theta equals beta. Then 1 theta is 20 degree. Second one, to calculate the theta in the third quadrant. So 180 plus beta. So 180 plus beta. So 180 plus 20 gives us 200 degrees. So again, we have two answers here. Let's look at example 7. Angle theta is principal angle that lies in quadrant 3, such that angle theta is greater than or equal to 0 and less than or equal to 360. Given each trigonometric ratios, determine the exact values of x, y, r, provide a sketch, determine the related angle beta and principal angle theta. So A, sine theta equals negative 2 over 5. So the question is telling you that this angle is in quadrant 3. Actually, I will start from part 2. First, I'm going to do the sketch. Then I will answer the first part, x, y. We are going to find x, y, and r values. Okay. So if the question did not tell you that the angle theta is in quadrant 3 and only gave us this value, sine theta equals -2/5, then actually you would have two possible theta values here. Because sine is negative in quadrant 3 and 4, then we had two options, two possibilities. But in this case, question is specifically telling you that theta lies in quadrant 3. So that's a help that we know now this angle lies in quadrant 3. So that is angle theta. So let's remember, so sine theta is y over r. So then we can say that r is 5 and y is -2. So r is 5 and y is -2. So we already know the y coordinate of the point, which is -2. Okay, so we can start answering now first part. So find x value. So we already know y is -2 and r is 5. So we don't know x. Again, we are going to use the reference triangle here. Okay, so let's call this x, and let's find the x coordinate of this point. So again, we can use Pythagoras. That gives us x squared plus, again, it is -2, but if you look at it as a side length of a triangle, so you can always take the positive value of it. So 2 squared equals 5 squared. X squared equals 25 minus 4. X squared equals 21. X we get plus and minus √21. Then check if we can take both values, or if we should take positive value or negative value. So we are on in the third quadrant. In the third quadrant, x coordinates are negative, so I cannot take positive √21, but only negative √21. Okay, so x is negative √21. So we answered first part, second part. Now third part. Determine the related angle beta and principal angle theta. So we can use this given ratio, okay, but again, we never do directly sine inverse of this -2/5. We always write the ratio of the related acute angle first. So we can say sine beta equals positive 2/5. And then we do inverse now, sine inverse 2/5. So that gives us 23.6 degree. Okay, so after finding beta, and this is beta here, right? So we can get theta. Theta is going to be 180 plus beta. So theta is 180 plus beta, and that gives us, we just add 180 to this, so 203.6 degree. Let's continue with part B. This time secant theta is given, that is -1.5. So again, so to be able to solve for theta, we need to work with primary trigonometric ratios. So we can write cos theta from here. But if you just do 1/1.5, so you will get a decimal value and you will have to round it. But since we are looking for exact values, and we need to find x and r, so instead of using this decimal value, that's what we are going to do. So we can write 1.5 as 3 over 2. So it is negative, so negative 3 over 2. Now to get cos theta, I can flip this fraction, and that gives me negative 2 over 3. So instead of a decimal value, I'm going to use this fraction. So we also know that cosine theta equals x over r. So r is always positive, so r value is 3, and looks like x value is negative 2. Okay, and the question is telling you that this angle theta is in quadrant 3. So we can sketch an angle in quadrant 3. So we know that x coordinate is negative 2 and r is 3. Okay, so we already did now part 2 here. Okay, so let's go back to part 1. Part 1 is asking you to write x, y, and r values. Just from the given question, we know that x is negative 2, r is 3. Now we need to find the y value. Again, we are going to use there's reference triangle and Pythagoras to find y. Okay, so we can do 2 square plus y square equals r is 3, so 3 square. So 4 plus y square equals 9, y square equals 5. And we get y being plus and minus square root of 5. Then check if y can be a positive value or negative value or both. So in this case, we are in the third quadrant. In the third quadrant, y coordinates are negative. Therefore, we can only take y negative y value here, negative root 5. Okay, so last part, finding angle beta and angle theta. First, we are going to use, of course, this ratio to write the trig ratio for related acute angle. So that gives us cosine beta equals 2 over 3. Now do the inverse. Cos inverse 2 over 3. So that gives us 48 degree. 48 degree. Again, we are in the third quadrant. So theta equals 180 plus beta. So again, this piece is beta here. 180 plus beta, 180 plus 48 gives us 228 degree. Let's look at the last example. Example 8, tangent theta is given, the negative 3 over 4. Again, we are working with theta between 0 and 360. So this is a reference question for number 12 in your textbook, okay, on page 300. Part A is asking in which quadrants could the terminal arm of theta lie? So let me draw x and y axis here. So given tangent value is negative, first you have to decide in which quadrants the tangent is negative. So all positive, only sine positive, only tangent positive, only cosine positive. So looks like tangent is negative in second quadrant and also in the fourth quadrant. Okay, so we have two possible answers here, theta 1 and the other one is in quadrant of 4, theta 2. Okay, so tangent theta is y over x, but see this is negative x over so y over x. You can write this negative 3 over 4 as negative 3 over positive 4, or you can write it as positive 3 over negative 4. Okay, so those are, so either y is negative 3 and x is positive 4, or y is positive 3 and x is negative 4. Okay, so let's put this information in our sketch. So one possibility again, y is negative 3, so this cannot be here, this should be the one. So negative 3 and x is 4. And the other one is y is positive 3 and x is negative 4. Okay. So if we answer the first, again, part A, so which quadrants? Quadrant 2 and quadrant 4. Part B, determine all possible primary trig ratios for theta. So we're doing part B now. So we're going to write trig ratios, all possible trig ratios, because we have two possible theta here. So let's write trig ratios for the theta that is in quadrant 2. Also, we're going to write trig ratios for the theta that is in quadrant 4. Okay, so tangent theta is already given, so I'm just going to write sine theta and cos theta for both possibilities. So sine theta is y over, so that is negative 4 and 3. Okay, and this point is 4 and negative 3. So to get sine theta, we need to do y over r, and looks like we need to calculate the r value here. So r square equals 3 square plus 4 square. So that gives us 9 plus 16. So that is 25. So square root of 25. Again, r is always positive, so we get positive 5. Okay, so r is 5 here. Okay, then sine theta is y coordinate over r, so 3 over 5. And cosine, x coordinate over r, so negative 4 over 5. So for the angle that is in quadrant 4, sine theta, negative 3 over 5. And cosine theta, positive 4 over 5. Part C, evaluate all possible values of theta to the nearest degree. So to evaluate the theta, actually first we're gonna get the beta. So let's remember, right? So this is beta and this is also beta. If we can find beta, then we can find those two possible thetas. So I'm gonna use, so I could use this sine theta and cos theta. Also I can use the original information. So it says tangent theta is negative 3 over 4. Again, we never do inverse from this. You always write the ratio for the related acute angle, and that is going to be positive 3 over 4. Tan inverse 3 over 4. That gives us almost 37 degree. So beta is 37 degree. So let's find the theta that is in quadrant 2. That is going to be 180 minus beta. So subtract 37 from 180. We get 143. So let's look at the other angle that is in quadrant 4. In quadrant 4, so theta is 360 minus beta. 360 minus beta. So 360 minus 37 gives you 323 degree. So those are two possible angle thetas. Okay, now you can start doing the textbook question.